Hi everyone. In our last class, we looked at 4 of the laws of indices. In today's class, we're going to be looking at the remaining laws of indices. So let's look at the 5th law of indices, which is what we call power law. We call it power law. Okay. Now what this is saying is that if you have a number which is raised to a certain power and is again raised to another power, what you do to this is that you multiply those powers together. What do we mean? When you have a number raised to a power which is again raised to another power, what you simply need to do is to multiply these powers. You have 2 and you have 4. So what I'm going to do right here is it's going to become 3 raised to the power of 2 times 4. So that means I have 3 raised to the power of 2 times 4, 8. That means my final answer is 3 raised to the power of 8. Take a look at another example right here. 2 raised to the power of 2 and then again raised to the power of 5. What you do right here is to say 2, this is the 2 right here, the base, raised to the power of, you multiply this power and this power is going to be 2 times 5. And then you're going to have 2 raised to the power of 2 times 5 is 10. Very good, guys. Very good, very good, very good. So that is basically what the power law is talking about. So that means in general, if you have something of this nature, a raised to the power of x, then raised to the power of y, what this will give you is a raised to the power of x times y, which is going to give you x, y. That is your power law. Okay. Now let us take a look at this 6th law, the 6th law of indices, which we have called the product power law. Products power law. Okay, what is this saying? It's saying that when you have the product of different factors which are in a bracket and they are raised to a certain power, the power is distributed over each factor in the bracket. What this means is that if I have these factors like this, 6ab inside a bracket and they are raised to a power, I'll call it 2. All you need to do here is to distribute the power over each of these factors. So how do I solve this? This is 6ab, everything raised to the power of 2. So I'm going to distribute this right here because 6 is 6 raised to the power of 1. That is what it means, right? So if you want to, you can apply the law that we treated right here, the power law, in which case we multiply this by this, right? 2 times 4 was, gave us 8, and then we said 3 raised to the power of 8. So the same thing we are going to do right here, that 6 is raised to power 1. So that means you're going to have 6. 1 times 2 is 2. Okay, then I can say times a. Remember, we are distributing this power to all the factors here. This a also is pretty much a raised to power 1, right? 1 times 2, that's 2. That is a squared. Times, okay, b also means b raised to the power of 1. 1 times 2 is 2, b squared. So that means in the end, I'm going to have 6 squared is 36. A squared, that's 36, a squared, b squared, because you're going to have 36 times a squared times b squared. This gives you your final answer. Okay, what about if we have this question right here? 6 a squared b everything raised to the power of 2. Take note, it's still going to be the same approach. Okay, it's still going to be the same approach, in which case 6 is pretty much 6 raised to power 1, right? So if you distribute this square on all these factors right here, you're going to have 1 times 2 is 2. Okay, times this is a squared, so it's going to be a. So if you open that, it's going to be 2 times 2, right? That's going to be 4. Remember your power law that we treated in law 5. Times b is b times 1, right? 1 times 2 is 2, so that's going to be b squared. Okay, now 6 raised to power 2 means 6 times 6, that's 36, times a raised to power of 4, that's a raised to power of 4, times b raised to the power of 2. Do you get that right now? So that is your final answer. So that is what the product law is all about. You are distributing this power to all the factors inside this. We distributed this also to all the factors inside this. I hope you all understand that concept. All right, let us take a look at the last law right here we're going to be dealing with today, which is what we call the fractional indices. Fractional indices. Okay, so now for this one, we're going to be looking at two ways, or we're going to be looking at two approaches right here. The first one is when you have this format, x raised to the power of 1 over a. Take note, fractional indices means your indices or your index is a fraction. We want to look at a case where your fraction is 1 over a number. And we want to also look at another case where it's going to be of this format, x raised to the power of a over b. Okay, so we are going to look at this format for us so that you all can understand these concepts. Okay, so the first thing we want to look at right here is, let's say we have 4 raised to the power of 1 over 2. So what the fractional indices is saying is that this denominator of the fraction is going to become a root. It's going to become a root. Now, what do I mean right here? Because this is 2, the denominator is 2 right here, it's going to become a square root. Square root of what? Square root of this base, 4. Okay? So if this denominator becomes square root of this base, which is 4, then your final answer is going to be, what is the square root of 4? That is 2. Okay, what about if I have 9 raised to the power of 2? Take note, your index is also here. Your index is also a fraction. And what is the denominator? 2. So it's going to become square root. Square root of what? The base. Your base is 9. 9. So what is the square root of 9? Square root of 9 is 3. Okay. What about if I have something like this? 8 raised to the power 81 raised to the power of 1 over 2. 81 raised to the power of 1 over 2. Because your fraction is also having denominator of 2 right here, it's going to become square root of 81. And square root of 81 is 9. Okay. I'm trying to show you a lot of examples right here so that way you can better understand this concept. What about if I have 27 raised to the power of 1 over 3? Very good. Remember we said if we have a fractional index, it means we are going to have a root. But it is the denominator that will determine what type of roots you are talking about. Is it a square root or a cube root or a fourth root? So now in this case, because your denominator right here is 3, you see that your denominator right here is 3, right? So what this means is that now you would have cube roots. Remember, for this other problem set, the denominator was 2, therefore we add square root. But here it is 3, therefore we have cube root. Now cube root of the base, which is 27. And if you remember your cube root very well, it has to do with what number will you multiply by itself 3 times to give you 27. The answer is 3. Very good, guys. Let us look at one more. 64 raised to the power of 1 over 3. That's still going to be the same approach because your denominator is 3. So that's going to give you cube roots of 64. And cube root of 64 is going to give you 4. Very good, guys. Very good, guys. Now, if you take note of the examples that we did, those are examples with numerators that are 1. If you look at it, our numerator was 1 here, also 1 here, and the other ones were also 1, right? What about if your numerator is not 1? It is a number greater than 1. Take, for example, I have 4 raised to the power of 3 over 2. What do we do? How do we solve this? Okay. Denominator right here is 2, which is going to be the same thing as what we did here. So that's going to be square root. Take note. Square root of 4. Okay. But right now, your numerator is 3. In that case, I would then say raised to the power of 3. I'm sure by now you should be thinking that, maybe that's why we did not use the 1 right here, because if we add this 1, we could also have said raised to the power of 1. And if your square root of 4 is 2, it's going to be 2 raised to the power 1, which is the same thing as 2. Do you get that now? That was why we did not really bother ourselves as much with the 1 right here in this case, because anything raised to the power of 1 right here is still going to give us that thing, right? But in this case now, we have a number at the numerator greater than 1. So now we are going to consider that a lot. So now this is 2 as the denominator, square root of 4. That is what it's going to give us, right? Now, square root of 4 is going to give you 2, okay? And remember, you have raised to the power of 3 right here. Then you bring that down, raised to the power of 3, okay? And now if you take a look at this, 2 raised to the power of 3 means 2 times 2 times 2 times 2. The answer is going to give us 8. 8 is our final answer. What about if we have another example like this? 9 raised to the power of 3 over 2. We are going to use the same approach by saying our denominator right here, right, is 2. Take note, denominator here is 2. So because the denominator is 2, it's going to be square root, right, of 9, because this is the base. And then what is the power? What is the power right here? The power right here is 3. Because the power is 3, then I'm going to have raised to the power of 3. So now, square root of 9, what is it? 3. Okay, very good, guys. Then bring down this 3 right here. So I'll bring it right here. Okay, so now I would have 3 raised to the power of 3. It means 3 times 3 times 3. The final answer is 27. Interesting, guys, interesting. I believe you all are understanding this concept. I will encourage you to pause the video, look at the problem set very well, and look at the solutions very well to better understand what we are talking about before you move on. Remember, you don't just want to watch the video, but you want to be able to understand the concepts that we are explaining right here. All right, let's take a look at one more example. 64 raised to the power of 2 over 3. We are going to use the same concept. The denominator is 3. So that is going to give me cube root. Cube root, guys. Cube root. What is the base? 64. That is cube root of 64. Okay. Raised to the power of, what is the denominator? 2. Very interesting, guys. Now, what is the cube root of 64? What number will you multiply together by itself 3 times to give you 64? That's going to be 4. So if I say 4 times 4 times 4 is going to give me 64, right? So now cube root of 64 is 4. Then this is square. I'll put that there. Now 4 square is 4 times 4, and that is 16. Very good, guys. Very good. The answer is 16. I hope you all understand this concept. I will encourage you to look at the video several times until you're able to understand this concept. In the next class, we are going to be looking at various examples of how to apply all these laws of indices that we have learned, so that way we can be able to perfect everything. If you are new on this channel, I encourage you to subscribe and click on the bell to turn on your notification so you don't miss any of our videos. See you in the next class.